This is Workbench from Workbench Quagmire with day 87 of our free code camp Python certification in 100-ish days. Today we are going to work on the build an adjacency list matrix converter lab. It's a mouthful. So in this lab you will build a function that converts an adjacency list representation of a graph into an adjacency matrix. As adjacency list is a dictionary where each key represents a node and the corresponding value is a list of nodes that key node is connected to. An adjacency matrix is a 2D array where the entry at position ij is 1 if there is an edge from node I to node j, and otherwise 0. So here's an example of the adjacency list. So our keys are our nodes. So node 0 or 1 is connected to node 1, 2, node 1 is connected to 2, and so on. And here's an example of that in a matrix. So node 1 is connected to 1, or 0 is connected to 1 and 2. 1 is just connected to 2. 2 is connected to 0 and 3, and so on. So objective, fulfill the user stories below and get all the tests to pass to complete the lab. So the first user story is you should define a function named adjacency list to matrix. Almost got it. To convert an adjacency list to an adjacency metric, the function should take a dictionary representing the adjacency list of an unweighted, either undirected or directed graph as an argument. So and the function should convert the adjacency list to the adjacency matrix, print each row in the adjacency matrix, return the adjacency matrix. First thing we want to do is look at what happens if you don't send anything in. So basically, the nodes. So how many nodes are there? Well, we can get the nodes. They're equal to we can make them a list of adjacency list dot keys, not key. Let's go ahead and start testing this. We will just use this first one. Let's copy this first. That is a long function name. We're gonna have to print it, I'm guessing. There we go. Now we feed in the dictionary. So this matrix is not defined. Let's make this narrower. Line 2 or 9. So it's missing one argument, and we get the argument Oh, it's a add list. See? List. So there we go. We got our nodes 0, 1, 2, 3. We return none. So we want to return count the nodes to figure out how many rows we're going to need. Three, the maximum node in this case. And then actually we're just going to return matrix. And the number of columns equals the number of nodes plus 1, or the max node plus 1, right? So n equals max node plus 1. Matrix is not defined. Make it an empty list for now. So then we can create the matrix with just zeros in it. So basically build the structure. 0 for. We use the underscore because we don't need anything in range. In. In range in. And there we go. We got our matrix. Two-dimensional matrix just filled with zeros. And then we need to fill the matrix based on the adjacent list. So we need a for loop. And list for V in adjacent list U and then matrix U V equals 1. So there, that's pretty simple. Basically going down through the keys in the list. And so we're saying, hey, this key, this other, or this node and then this node, and we just make it a 1. So now we have to do the printing part. Basically we have to just print row in the matrix, it looks like. So another loop for row in matrix, print row. Let's take the print statement out of this. Now that we're print basically built in. There we go. That looks a lot better than what we were returning. Let's see if we passed our tests. We did. We passed everything. All right. That was great. So that didn't take very long at all, actually. Next time we'll do this workshop Looks like a pretty short one. We should be able to do it in one day, one sitting. And then we will move on to a couple more labs, and we are almost done here, with the exception of probably this amount of studying you're going to need to do to pass this certification. So thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time.